Alright, so here I've got the coin and I've got a turntable. The turntable has low friction ball bearings, so it goes for a pretty long time. The only problem is I can't really get a consistent angular speed. So we're going to do this from a qualitative perspective as we test out the equation that we derived here in class for the angular frequency or angular speeds that will allow friction to hold the coin on the turntable. So first thing, I'll put it on here to get some sort of baseline, and I'll start it off here, and I'm going to get going faster and faster and faster and faster and faster. And of course, eventually it goes too fast. I've exceeded the range of values that omega can have. All right, so let's change some things here. Let's change, for example, how close it is to the center. And so by decreasing r in the equation, what should happen to our range of values of omega? Right, it should get larger, right? And so let's see what happens. So I get it going faster and 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 faster. And we saw that it stayed on for a longer amount of time for a larger range of angular speeds. That makes sense. Okay, so what if I put it right in the middle, where r goes to 0? What should that do to the range of values of angular speeds? Good, because really as r goes to 0, this fraction blows up and omega approaches infinity. Ideally, it should never leave. So let's try it out. Obviously, I can't get it right in the center, but let's try it out. Okay, so you can see clearly I got it going very, very fast there, at least as fast as I could get it going, but certainly it wasn't exactly in the center, so eventually it left. Okay, so what else can we change according to the equation? Well, we really have no control over g, so let's change mu sub s, and that's what these rough patches are for here. So this is a rougher patch. What should we expect to happen? Of course, we should have a larger range of omegas. Okay, and it stayed on there for quite a while because it was rougher, there was enough friction to hold it on for a larger range of omegas. Now, when we derived this equation, what dropped out? Right, the mass. So it means it shouldn't matter what mass there is. So let's put the coin here and a 200-gram mass here, which is many more times massive, and I'm going to get it going, and we'll see what happens. We'll get faster and faster and faster and faster. And we saw that they left at the same time, really at the same speed.